In this video, we're going to talk about supplemental examples from 7.4. So let's go ahead and look at this one where we find the distance between 2 points, first using the distance formula and then using integration. So A, we're going to say that our distance here is going to be S. We're going to use the square root of x2 minus x1 squared plus y2 minus y1 squared is equal to the square root of x2 minus x1 is 3 squared plus 3 minus 1 is 2 squared. So s is going to be the square root of 9 plus 4 is the square root of 13. For b, I'm going to say s is going to be the integral from a to b, square root of 1 plus f prime of x squared dx, where f prime of x is going to be my slope of my line here. So since it's linear, my derivative and my slope will be the same thing. So let's go ahead and find y2 minus y1, x2 minus x1 is 2/3. So s is going to be from 2 to 5 on x, square root of 1 plus 2/3 quantity squared dx. S is 2 to 5 of 1 plus 4/9 is 2 to 5 of square root of 13 over 9. And s is root 13 over 3. Interval of 2 to 5. And then this is dx is root 13 over 3 times x from 2 to 5. Root 13 over 3 is 5 minus 2, which is 3. So s is root 13 over 3 times 3 is root 13, and units and units. Much faster to use the distance formula, but same answer. So let's find the arc length of y equals 3/2 x to the 2/3 over 1 to 8. So I'll need y prime, which is going to be x to the negative 1/3. So s is going to be integral from 1 to 8 of the square root of 1 plus x to the negative 1/3 squared dx. This is going to be 1 to 8, 1 minus x to the negative 2/3 dx. It's 1 to 8, 1 plus x to the negative 2/3 that was. So plus x to the 2/3 in the denominator for 1. I'm going to make a common denominator here, and s is equal to 1 to 8 of x to the 2/3 plus 1 square root x to the 2/3 as my common denominator. Dx is going to be 1 to 8 square root of x to the 2/3 plus 1 over x to the 1/3 dx is going to be s is 1 to 8 Square root x to the 2/3 plus 1, x to the negative 1/3 dx. U is going to be x to the 2/3 plus 1. Du is going to be 2/3 x to the negative 1/3 dx. So I need a 2/3 to fix this and a 3/2 on the outside to complement that. S is equal to 3/2. Let's go ahead and change everything to u here. So if x is 1, u is going to be 1 plus 1 is 2. If x is 8, cube root of 8 is 2. 2 squared is 4. 4 plus 1 is 5. This is u to the 1/2 du. So that's 3/2 u to the 3/2 times 2/3, 2 to 5, and these will make a 1. This is s equals 5 to the 3/2 minus 2 to the 3/2. That's going to be equal to the square root of 125 minus the square root of 8, and that's approximately 8.352. You could also make this 5 root 5 minus 2 root 2 if you wanted to. Same approximation there. Okay. Moving on, find the arc length of y equals 1/2 times e to the x plus e to the negative x. If you recognize this function from chapter 5, this is hyperbolic cosine. So y equals hyperbolic cosine of x from 0 to 2. So let's deal with it this way first. That makes y prime equal to hyperbolic sine of x. So we want s equals the integral from 0 to 2 of the square root of 1 plus hyperbolic sine squared of x dx. Now you may not know that hyperbolic trig identity off the top of your head, but that is the trig identity for hyperbolic cosine squared. So s is equal to integral from 0 to 2 of hyperbolic cosine, which is hyperbolic sine from 0 to 2. So that's hyperbolic sine of 2 minus hyperbolic sine of 0. So stick that into your calculator, and that's about 3.627. Can you do that with the function as it is written? Absolutely, you can. Let's go ahead and try this way. If y is equal to that right there, then y prime is equal to 1/2 of e to the x minus e to the negative x. Y prime squared, which I'm going to need, is going to be 1/4 of e to the x minus e to the negative x squared, which is 1/4 of e to the 2x minus 1 minus another one is minus 2 plus e to the negative 2x. So we're going to have 1/4 e to the 2x minus 1/2 plus 1/4 e to the negative 2x. So when I have 0 to 2 of the square root of 1 plus y prime of x squared, turns into 0 to 2 of this negative 1/2 plus 1 becomes a positive 1/2. So that makes that 0 to 2 of the square root of 1/4 here times e to the 2x plus 2 plus e to the negative 2x dx. 1/4 comes out as a 1/2, 0 to 2, and this is the square root of e to the x plus e to the negative x squared dx. 1 plus 1 is going to give me that 2. So this is going to be 1/2 of the integral of 0 to 2 of e to the x plus e to the negative x dx is 1/2 of e to the x minus e to the negative x from 0 to 2 is 1/2 of e squared minus e to the negative second minus e to the 0 plus e to the 0. So those go away, and this is going to give me about what I said before, 3.627. Go ahead and check that in your calculator here both ways. 0.5 times e to the second minus e to the negative second there it is. And let's look here. You don't have hyperbolic trig functions here, so you have to go into catalog and look for it. So letter S right here. There it is. Sinh 2 minus, and then come back here again. Sinh 0. Same thing. Exactly the same thing. In your they're somewhere else in here. I can't remember if they're in doesn't look like they're in math. Maybe they're in angle. They're somewhere around, hiding in another menu somewhere too, but you definitely can get to those in the catalog. So all right, moving on now to the next problem, which is to write and evaluate the definite integral that represents the area of the surface generated by revolving the curve. Y is equal to 3x about the x-axis, and on the interval from x goes from 0 to 3. So y equals 3x. We have a slope of 3 here, very steep, between 0 and 3. We're going to have the point up here 3, 9. We have 0, 0. I'm interested in this bit right here between 0 and 3. I want to revolve it about the x-axis right here. Easiest to make a rectangle going this way, and that's perpendicular to the axis of rotation, so that's going to be disk washer. So surface area. So surface area, this is a good one. So surface area is equal to 2 pi integral from a to b of r of x square root of 1 plus f prime of x quantity squared dx. So capital S is going to be 2 pi 0 to 3 of this function here is 3x square root of 1 plus, and the derivative there is 3 squared. So that's 10, 3 times 10. So we have 2 times 3 is 6. Pi times the square root of 10, integral from 0 to 3 of x dx, and give us capital S is equal to 6 pi root 10 x squared over 2. 2 goes into there 3 times, 0 to 3. So I have 3 pi root 10 from squared minus 0 squared. So 9 is 27 pi root 10 exactly. And that is going to be surface area, so that's units squared. This was arc length, so these are units. And this was arc length, so these are units. And those are units. All right, that's it. So we'll come back next time and we will talk about supplemental examples from 7.5. See you for the next video.